do a little review from what we did last week. Recall, we have these properties of logarithms. That the log of 2 plus the log of, let's say, 4 will equal the log of 2 times 4. And the base doesn't matter. It's true for any base. I'm going to use base 2 just for the example because it's nice numbers. So just to verify, what is log of 2 base 2? What does that equal? So what is this question asking again? You might need to recall this. This is saying 2 to what power is 2? Right? Yeah. So this is saying 2 to what power? Think of this little 2 here. Think of it like a little empty box. Okay. 2 to what power is 2? That's 2 to the 1 is 2. Right here. Log of 4 base 2. 2 to what power equals 4? 2. All right. And that should equal, what is 2 times 4? That's 8. 2 to what power is 8? 3. Yeah, so yeah, 1 plus 2 equals 3. So it works. We add the individual exponents. That's the same as just multiplying them and then finding the logarithm. We can verify it that way. Let's see here. Flip it around here. We have log of 4 minus the log of 2. We said that's going to be the same as the log of 4 over 2. And again, we'll do all base 2 just to make it nice numbers, but it doesn't matter what base it is, it works. So let's just stick with some nice numbers. So once again, from above, we know the log of 4 base 2 is 2. The log of 2 base 2 is 1. The log of 2 base 4 over 2, which is 2, is again 1. So 2 minus 1 equals 1. It works out. So subtracting the logs is the same as dividing. Subtracting logs, same as dividing. If you need to look at it another way, you might remember that we have 2 to the 2 times 2 to the 4. That equals 2 to the 2 plus 4. So when you're multiplying and adding the exponents, it's the same as multiplying. And similar here, if we had 2 to the 4 over 2 to the 2, that's the same as 2 to the 4 minus 2. So dividing is linked with subtracting the exponents. Remember, a logarithm, the answer is an exponent. So if I ask you what the log of 2 is, you're like, I don't know, like calculator. You should be thinking the answer is an exponent. Whatever my answer is, it's the exponent. And you might think, okay, 2 to what power is 2? Okay, the exponent is 1. Always link these these new symbols and new word in the middle of your math problems with, okay, it's simply an exponent, nothing more. It's not a mysterious thing. Think of it like a square root. We did quadratics forever, then we did square roots. This is like the square root of a quadratic. It's versus some powers. This new little word in the middle. We had another one, another power. We didn't really talk about it too much. We use it a lot today, though, so I'll simplify some few things. That is, we have something like this. We have the log of 4, base 2, the log of 4 to the 3rd power, base 2. It's a shortcut, really, is what it is. It's going to be useful. Not that it'll make it that much shorter, but enough. So how would we normally solve this? All right. This is what we did before. We just said, all right, what's 4 to the third power? 4 times 4 times 4, and you get 64. Okay, no problem. And then what's 2 to what power is 64? 2 to what power is 64? 6. Okay. So that's how we normally solve it. Okay. Here's another way. That's maybe a shortcut. Ignore the exponent. Okay. What does that equal? If I just forget the 3, there's a 3 up there. Ignore that for a minute. What do you get? What's 2? 2 to what power is 4? 2. And there's a 3 left over. Using that 3 in our answer, how can we get an answer of 6? Multiply. So there's a little faster way. If you're being raised to a power, what you can do is just simplify this part and then multiply that answer by that exponent. So it's a little bit faster. Another way of looking at it is that the log of 4 base 2, that's raised to the third power, is the same as just 3 times the log. In motion, really, the exponent just comes down in front and you multiply it. That's really what's going on. It's a shortcut. You can see you get the answer either way, right? And without relatively too much work. But when I ask, 2 to what power 64, people are like, not for sure in my head real quick what the answer is. But when I ask you 2 to what power is 4, I said, okay, 2. So mentally, it might be a little bit easier to use this method. Get the answer of 2, and then 2 times 3 is 6, as opposed to 2 to what power 64, okay, 30, 16, 32, 64, okay, 6. So it might eliminate a few mental errors, if anything else. So we'll use this today as well. Okay, now let's take a look at some of this fun stuff. Went over those already. And again, as I mentioned, we're just going to do all this from the worksheet. Do not do all the work and squeeze it in on the worksheet. Use another piece of paper so it's nice and clean, easy to read. Hello. There we go. Okay, watch me on a few of these. You can write the question down, but just watch me do it. I don't want you to get caught up in the little, what do I do next, what do I do next, what do I do next. I want you to see this big picture first before we start. And I'll make this whole thing, when you're looking at it, might look like, wow, that's a lot of, that's going to be a lot of work. Okay? I want you to see me go through them actually at a faster speed, and you're going to see they break down into this, the warm-up. They just break down to these types of questions. So if we can solve these from the warm-up, that's really what you end up doing. Okay? That's as difficult as it's going to get. Okay? But if you get caught up in all the details and all these logarithms all over the place, it might seem more complicated than it really is. So when you see addition, what should you be thinking? Multiplication. Okay? So if I add 2 logs, I'm really multiplying them. Okay? Log of 9x equals log of 54. Okay. 9x equals 54. X equals 6. Okay. Nothing more than that. Okay, so you think multiplication. I got an x, I got a 9x. We have a log on both sides. It's not that it cancels out, but we ignore for the time being. We're trying to solve for x. So we're trying to figure out log of 9 times what is going to give us 54. Yeah, well, log of, with 6, x equals 6, then you'll have log 54 equals log 54. Nothing more than that. Okay? It breaks down to a very simple algebra 1, equation to solve. Nothing more than that. Looking at the second one, again, you see addition, you think multiply. Okay. Showing work. I'm going to do n minus 3 times n plus 4 equals 1. Now here, the base actually matters. So we have our two different types of problems right here in front of you. You have the type of problem, it's the first type, where you have the log on both sides. Once you get a log equal to a log, you can pretty much just drop those off. It's not that they cancel out, that's not what I'm doing, but that's in a sense what the next step is going to be, just 9x equals 54. Then we have this kind where you don't have a log on both sides. In this sense, what you do is this. You do the, basically convert it to exponent form. Eight to the 1 power. Remember, our answer to a logarithm problem is an exponent. So this answer becomes the exponent. Our base is always right here. Okay. And then we solve that. And then from here, just quadratic work. We have to know how to solve that. But you can see, in the first step or so, everything we're doing right now, this whole logarithm business, it turns into like, okay, solve this linear equation, solve a quadratic, solve something with a square root. Okay, in like 1 or 2 steps, it breaks down to something from algebra 1 really fast. So some people look at these and say, ah, these are really hard, difficult. Really, not too bad. Pretty good for a Monday. Do we need to solve this, or are we okay? Want to solve it? Okay. All right. So we got what? N squared with plus n minus 12 equals 8. Right? So I did basically, since there's no coefficients on the ends, we just did 4 minus 3, got 1. Negative 3 times 4, we got negative 12. 8 to the 1 is 8. Subtracting it on both sides, 20. So with quadratics, remember to solve them, you have to get equals 0. That's the goal, first goal anyway, solving quadratic. Get it equal to 0. And then we can go ahead and factor. So what two numbers multiply to negative 20, add to 1? Yeah, 5 and negative 4. And so our answers are negative 5 and positive 4. Okay, is that it? No? What else? All right, so check your answers. Do they both work? Good. So if you plug in negative 5, does it work? Negative 5 minus 3 is? Negative 8. Can you take the log of negative 8? No. Yeah, so we throw out negative 5. And then 4, see if that works. 4 minus 3 is 1. Okay. 4 plus 4 is 8. Okay, so we'll get 0 plus 1 is 1. So it does work. So yeah, do check your answers. Do check your answers. Okay. Not too bad. So algebra 2, from here to here, algebra 2. From here to here, algebra 1. Just solving a quadratic. Or more of them are kind of like the warm-ups. They're just a linear equation where you probably don't need to do a lot of checking at all. Oh, and one more time. There's two types. Two types. When you get the log on both sides, a little bit easier. Once you have one log on each side, you basically drop off the logs and just say, well, whatever this is equal to whatever that is. You have to have only one log on each side. And then just, okay, 9x equals 54. And then the second type is when you have only one log, and then we just have to simply take the base, say, okay, 8 to the first power, and set it equal that way. So just maybe get good at identifying which is which. And then we'll practice a few more. So what about here? What do we do? Is this like the first example or the second? First, log on both sides. Okay. Showed the work. It looked like this. And then log on both sides. There's a quadratic to solve, kind of like the solving of the second example. 3m squared minus 5n minus 2 equals 0, and solve. I'll leave that to you to do. What about 18, setting it up? Log of b times b plus 3 equals the log of 4. So b times b plus 3 equals 4. So real fast just turns into a quadratic to solve. Again, these are numbered the same way they are on the worksheet. And just for kicks, b squared plus 3b minus 4, 0. I did 2 steps there. I distributed this, and I subtracted 4 on both sides, so it's equal to 0. So we have, what? Minus 3, minus 1? Okay. Minus 4 plus 1. Okay. So b equals 4 and negative 1. Do they both work? 4 plus 3 is 7. Okay. Negative 1. Negative 1 plus 3 is 2. So does it work? How we doing? Or is this wrong altogether? All right, tell me what it is. Positive 4, minus 1. So the answer is negative 4 and positive 1. Good. Glad you guys are doing it with me and not just looking up and looking down and copying it. So negative 4. Does negative 4 work here? No. Yeah, negative 4 plus 3 is negative 1. We cannot have log negative 1. That doesn't make sense. Just real quick, remember our graphs for our logarithms look like this. It's impossible to get negative. Okay. Negative exponents are all these fractions. They're fractions and not negative numbers. We cannot get a negative number. All right, so we throw out that, we get an answer of 1. Is there any more? All right, 12? Subtraction, right? What do you think? So log of what? 48 over W equals log of 4. Log on both sides. 48 divided by what equals 4? 48 over what is 4? Just 12. Just 12. 19. Log of t plus 10 over t minus 1 equals log of 12. Log on both sides. T plus 10 over t minus 1 equals 12. And you already did the work on the warm-up. Letter B. And we should be putting the bases in here. It doesn't really matter too much. When you have a log on both sides, the bases were not used. So when you have a log on one side and a number on the other side, that's when we have to change it to exponential form using the base. So hopefully after doing a few of these, you can see it just breaks down. If we can solve Algebra 1, this is going to be an easy homework. Not as easy as Friday's homework, but still pretty easy. Okay? But if we struggle a little bit in Algebra 1 and solving those quadratics is still kind of slow, it's a good review. So either way, it's a win-win. Let's see here. Let's see here. When we get to something that's, we've already done that. We can do that. No sense. Throwing a little mix it up just a little bit. Actually, you know what? No, we don't have that much. Not happy with this. It's messing things up. I don't have numbers there. It's just like everything prior. There's no coefficients, there's no numbers. But we have that, that last property we just talked about. The number in front here, it's like an exponent up here. I'm taking those and I'm moving coefficients up here. Now it looks pretty much like what we've been doing. So one of the cardinal rules in math is that once you come to a new problem that looks different, change it into a problem that you already know how to solve. I don't know what this is all about when I have stuff in front. I do know how to solve it when there's nothing there. Therefore, do I have a property or somehow that I can, get rid of this? And we do. All right. So we have what? Log y equals log of 16 to the negative 1 over 64 to the 1/3. What's 16 to the negative 1 and what's 64 to the 1/3? So 1 over 16 and then over 4. What does that equal? Put in your calculator, see what you get. 1 over 16 divided by 4. Breaking 1/16 into 4 equal parts. So yeah, we have to do a little simplifying. Nothing we can't handle. So most of them will just stream right through every now and then. All right, we'll have to maybe use that power. Anything else? Log of x plus 2 divided by 3. So here you see how many logs on the left. 1, 2, and then 3. Okay. Work from left to right. So the first two, what do these two make if they're addition? Log of what? 2x. You know, log of 2x minus log of 3, log of 72. And then do one more step. Now it's subtraction, right? So 2x over 3. So work from left to right. 2x over 3 equals 72, and we can solve. Oh, there's a 2 there? Oh. Yeah. So there is a 2 there. I gotta stand closer. So that's x. Back that up a little bit. Two in front. So we got what, log of x? Oh, okay. So that's going to be x squared, right? X and the 2 x squared will become x to the third. X to the third and then you have log of x to the third over 3 equals 72. Okay. Okay, and we can solve that. Well, let's do the best of what we got right now.